In Chapter 9, you're going to learn about quadratic functions, okay? Quadratic functions have a whole bunch of different properties, and today is just going to be the introduction of quadratic functions and their graphs, just kind of a general overall property of what they look like. This Get Ready is kind of neat if you want to take a moment to do it. It talks about how whenever you drop something, anything that's dropped will follow a quadratic formula, but we're going to talk about that a little later, so let's just keep moving on. One of the most important things today is this little paragraph and that you understand the different things inside of it. The quadratic function is a type of non-linear function. Now, what does it mean to be non-linear? Well, what word is in linear? A line, right? So non-linear means it's not a line. Okay, so it's not going to be a straight line today. It models a certain situations where the rate of change is not constant. Okay, that means that as something is changing, it's either changing really fast or it's changing slow. The graph of a quadratic function is a symmetric curve with a high and a low point that correspond to the max or the min. So you have a heads up, when we graph these today, they're either going to look like a U shape going up or a U shape going down. These U-shaped graphs are called, this funny word, parabolas. You're going to be focusing a lot on this word as we go through Chapter 9. Today is just an overview of what a quadratic is and how the shape looks on a graph. Alright, the key concept here is a quadratic function. It can be written ax squared plus bx plus c. A cannot be 0, because if a was 0, there would be no x squared term. And this is called the standard form, which you're used to seeing. Here are examples of 3 different types of quadratics. What's the same in all the examples above? You should notice they have an x squared term. That's what makes something quadratic. And we've talked about that last chapter, didn't we? About naming polynomials by how many terms they have and what their degree was. All of these will have a degree of 2. In fact, let's write that down. Degree of 2. That's what quadratic means. Moving on. You have the most simple form of a quadratic, and it would be f of x equals x squared, which is just a fancy way of writing y equals x squared. That's as basic as it gets. Now, when something is as basic as it gets, we call that the parent function, because it's like what all the other equations come from. Something that might be beneficial to you is knowing what the xy chart looks for these. A typical xy chart, I like to start with -2, -1, 0, 1, and 2. And if you plugged all those in for x squared, remember y is simply x squared, you would do -2 quantity squared, you'd do -1 quantity squared, 0 quantity squared, 1 quantity squared, 2 quantity squared. And watch what happens when you square all these numbers. You get 4, 1, 0, 1, and 4. Notice how the y side is reflected around this middle term 0, 0. By the way, that's something we call the vertex. That's your middle point of a parabola. It's your reflection point of your parabola. I think you know, but let's just make sure that you understand that if you graphed this, that would be the point -2, +4, which, look at your graph, would be right here. And then this would be the point -1, +1, which would be right there. This would be the point 0, 0. This would be the point 1, 1. And this would be the point 2, 4. And that's why the graph looks to be U-shaped, because as it continues, it keeps that U shape if you were to plot more points. The graph of the quadratic function is a U shape, we talked about that, called a parabola. We did talk about that. The parabola with the equation y equals x squared is shown above. Moving on. You can fold a parabola so that the two sides match exactly. This property is known as symmetry. The fold, or the line that divides the parabola into two matching halves, is called the axis of symmetry. Something to note about this is that your axis of symmetry will always be x equals a number. Okay? The reason, and that's just a star, that's nothing important, I was just putting a star there because it's important. The reason it's x equals a number is because it will always be a vertical line. The highest or the lowest point of the parabola is what we call the vertex. That's why up here I labeled 0, 0 as your vertex, because it was the lowest point. If a is bigger than 0 in our equation, the parabola opens upward. Now what does it mean to be bigger than 0? It simply means that a is a positive number. If it's a positive number, it opens up. Let's draw a graph of that. There's your graph, it opens up. The vertex is here's the vertex. What do you guys think that is? Would that be a minimum or a maximum? Hopefully you're noticing it's at the very bottom. So if it opens up, it actually has a minimum. Now let's pretend that a is smaller than 0. Well, what does it mean to be smaller than 0? It just means that a is a negative number. The number in front of x squared would be negative. If that's true, it opens downward. Therefore, the vertex is the maximum. Let's take a look. Here's a parabola that opens down. Notice at the very top, there's a maximum. Let's keep moving on to problem 1. Identifying the vertex. Can you write beside vertex, write minimum or maximum? Because that's all a vertex is. And you'll learn a lot more about a vertex as we continue through chapter 9. What are the coordinates of the vertex of each graph? Is it a minimum or a maximum? Take a look at part A. Do you see how the parabola opens down? Find the very tippy top of this. It's going to be right here. Well, what is that point? Let's label it with a capital V. How much over? 0. How much up or down? Positive 3. That's your vertex. 0, 3. It's the point on the graph. Is it a minimum or a maximum? Well, that's like asking, is the highest or the lowest point? It's the highest point, so it is a maximum. Just as a side note, on this problem, since it opens down, a would be negative because it opens down. Let's go to part B. Take a look at this graph, this parabola. Let's go to the very bottom. The vertex is right there. Let's write a capital V because that's how we label vertex. It's over to the right 1, so we use positive 1, and down 1, so we use a negative 1. That's the point. Now take a look at this graph. Is it a minimum or a maximum? Hopefully you'll tell me it's a minimum. And as a side note, a in this problem, because it opens upward, a would be positive. Let's keep going. We have one more. It says, what's the vertex of the graph at the right? Is it a min or a max? Take a look at your graph. Notice the highest or the lowest point occurs right here, at the very tip. That's at -2, -3, so we'll write V for vertex, -2 for x, -3 for y, and since it's the lowest point, it's a minimum. Let's say one more thing about this. Would a be negative or positive on this problem? The number in front of x squared is what I'm referring to. It would be positive because it opens up. On problem 2, we're going to take a note about graphing. If you graph and there's a fraction, pick x's that are multiples of the denominator. And that's going to help you get a lot nicer graph. Graph a function y equals 1/3 x squared. Make a table of values. What are the domain and range? For today, when you make your x and y chart, when they want you to graph an equation, I want you to put 0 in the middle. Now if you plug 0 in, you will get 0 out. Let's plug a little lower than 0. Now you might think to go to -1, but since this is a fraction and the denominator's 3, I actually want you to go to -3 and then to -6. We want to get a really nice graph. Why don't we also go to -9? Do the exact opposite going up. You're going to plug them in accordingly. Let's plug in the positives. 1/3. Quantity 3 squared. Now if you're wondering why I'm plugging it in, it's because it told me y is 1/3 of whatever x squared is. Okay, so 1/3 x squared. Well, 3 squared is 9. 1/3 of that is 3. Plug 6 in. 1/3 6 squared. 6 squared is 36. 1/3 of that is 12. 9. 1/3 of 9 squared. Well, 9 squared is 81, and 1/3 of that is 27. If you do the same thing for the negatives, remember to put the negatives in parentheses. Everything. Anytime you plug an x in, it's a good idea to put it in parentheses. And if it's not in parentheses with the negatives, it will be wrong. Okay, so we got them all in. If you put them in your calculator, or hopefully use your brain, you'll get 3, 12, and 27. Notice how 0, 0 is right smack dab in the middle. Plot your points. 0, 0 is here. Now, I am going to, on my x-axis, I'm going to skip by 3's. It's going to make graphing a little easier. On my y-axis, I'm going to skip by 3's again. Alright, so let's plot our point. -9, 27. 3, 6, 9, 3, 6, 9, 12, 15, 18, 21, 24, 27 is right here. Remember, I'm skipping by 3's. -6, 12. -3, -6. 3, 6, 9, 12. Okay? -3, 3. -3, 3. Alright, 3, 3. Right 3, up 3. 6, 12. Right 6, up 12. Pause the video if you need to take a little longer. 9, 12. 9, 27. Over 9, up 27. See the nice U-shaped graph that you get? That's your parabola. Extend your lines out, make it look like a U. This question does ask what the domains and the ranges are. Again, pause the video if you're still graphing. Now domains, you've learned this. Let's see how well you have retained it. Domains and ranges. Think before, domain and range, think before you answer. Is domain x's or y's? Hopefully you remember that domain are the x's. Therefore the ranges are the y's. Alright, Mr. Like has taught you this, so you really have to think back. When you make like a forever one way and a forever another way, you write infinities. Look at the x-axis. Can you see how it's extending forever to the left? If you continued this, it's going to go forever to the left, and forever to the right. Therefore, your domains go from negative infinity to positive infinity. And that's always the case with these type of parabolas. That means that you never finish going negative and you never finish going positive. You can plug in anything you want for x. Now let's talk about the y's. This is a little harder. Does this one, I like to do this, does this one have a negative infinity or a positive infinity as you travel on your y-axis? That's like asking, does it go forever up or forever down? Hopefully you're answering it goes forever up. If that's the case, it has a positive infinity. Put that on. Now the question is, does it go forever down? Hopefully you answer no, it does not go forever down. It stops right here. Well, what is the y value here? 0. You write a bracket on it because it does exist at 0. And you say it goes from 0 to positive infinity on my y-axis. One small note to make is your axis of symmetry. I know it didn't ask for it, but it's a good thing to learn. Your axis of symmetry is the line that you can like take your parabola and fold it. Well, hopefully you realize, let me get a pencil. You see where I'm putting the pencil? If you fold the parabola around this pencil, you get the same picture. What's the x value here? 0, right? So the axis of symmetry is x equals 0. Let's try graphing one more, and then we'll start a new video. Graph the function y equals negative 3x squared. What's the domain? What's the range? There's no fraction to worry about on this one. So when I make my xy chart, I'm going to go to 0, and I'll do negative 1, negative 2, negative 3 to have a nice picture. 1, 2, 3. Really, you just have to go to 1 and 2, but doing what I'm doing is going to give us a much better picture. So we have y equals negative 3 times x squared. Well, let's plug in 0. Negative 3 times 0 squared is 0. Let's put in our positives. Negative 3 times 1 squared. Well, 1 squared is 1 times negative 3 is negative 3. I ran out of lead. Hold on. Okay, there we go. Now let's plug in 2. Negative 3 times 2 squared. Well, 2 squared is 4 times negative 3 is negative 12. And 3. Negative 3 times 3 squared. 3 squared is 9 times negative 3 is negative 27. You can trust me, or if you wanted some extra practice, the points up here will be exactly the same when you plug them in. Let's graph, and I'm going to encourage you to skip by 3's on your y-axis. In your x-axis, you don't need to skip by anything. So I'm going to say x-axis by 1's and y-axis by 3's. Alright, negative 3, negative 27 would be left 3, down 27. But remember, I'm skipping by 3's. I ran out of a graph, so I'm just going to have to keep going. Be right about there. If you run out of graph, just pretend there's more room. Okay, negative 2, 12. Left 2, down 12. Remember, I'm skipping by 3's. 6, 9, 12. Negative 1, negative 3. Remember, I'm skipping x's by 1's and y's by 3's. 0, 0. And the other side is going to be a perfect reflection. Take the time, pause the video if you need to check your answers. Plot your points. Connect. Get a nice U shape. Don't make it messy and don't make it look like a V. It's not a V, it's a U shape. When you're done, check your answers with the video, and let's talk about the domains and the ranges, capital D and capital R. Remember, domains are X and ranges are Y's. The domains go forever to the left, that's negative infinity, and forever to the right, that's positive infinity. The ranges, since this graph points down, it goes to negative infinity, not to positive infinity, and it stops at 0 on its way back up. So we write 0 with a bracket because it does equal 0. If I asked you about the axis of symmetry, you would tell me it's x equals, and what's the line that you folded around? This line right here where I'm placing the pencil. And what does x equal at this line? X equals 0.